Okay, let's go to page 219, and this is section 18.5, and this is pyramids and cones. Okay, so the difference between this and this is that, okay, prism and pyramid have the polygon base. Okay, now this one you have the two bases. You have the top and the bottom are identical. Pyramid and cones are pointy tops, so you only have a single point. Okay, so example of that would be the cone would be circular base, and you have a point on top like this. Okay, the pyramid. Okay, let's say if you have a square or whatever polygon, and you have a point out here. Okay. Okay, and that's it. Okay, so you can see the difference. So the prism, you got two base. You have the top base and the bottom base. The pyramid, you only have the base on the bottom. Same thing with the cone and the cylinder. Cylinder, you have the base on the top, you have the base on the bottom, and the cone, you have one point. Okay, and you have the base on the bottom. Okay, and the point from the vertex, you go straight down. This is the altitude, is h. So from here you go straight down, is h. Okay, again, this would be the right circular cone. Okay, because sometimes the cone can be like at an angle. Okay, and the cone can also have this is circular cone, whereas sometimes you can have an oval. So you can have the oval base. Okay, so it does not have to be a circle, but normally we deal with a circular cone. So when we talk about cone, we usually think of it as a circular cone. Okay. Okay. So now to find the lateral area of the cone. So let's say you have a cone, right? And you cut and you open, you're going to end up with something that looks like this. Okay. So if you have a cone, you cut and you open. Okay. So this is called a lateral edge, so it will be L, okay. So, and the circumference will equal to 2 pi r. So when you cut it open, this will be a 2 pi r. Okay. Now, what you do is to figure out the area, you can think of it as a triangle, because you can cut this into infinite number of small triangles. Okay. So and if you line it up. Okay, so the area of the triangle would be equal to 1/2 base. Okay, so I'm going to call this B1, B2. So B1 plus B2 plus B3 plus to the B to the n. Okay, so 1/2 base times the height. Okay. Well, if you add all this base, notice this is your B1, B2, B3 to the Bn, right? If you add all these together, what is this? Well, that's your circumference, that's your 2 pi r. Okay? So you can think of a triangle as 1/2 base times height. Okay? And your height would be, in this case, would be L, right? So K will equal to 1/2 2 pi r times L. The height would be, now this H is not this H, okay? Because when you open it up, the height of the triangle would be like over here. Okay, when you cut it really, really thin, okay, infinite number, and the 1/2 and 2 will cancel out. So area of triangle would, of this cone would be pi r L. Okay, but the formula sometimes is kind of hard to memorize. The way to memorize is just, instead of trying to memorize the floral formula, just think of it as triangle. So you have a cone, you cut, you open, okay, you open, you end up with this, right? And this would be the L, right? And this is a circumference, so this would be 2 pi r. So just think of it as triangle. So area of a triangle is 1/2 the base, right? That's your base, 2 pi r, and times the height, which is L, and this cancel out, and that give you that. Okay. So think of it as a triangle. It will work out the same as a triangle. Okay. Now for this one, again, you open it up, you're going to have a different triangles. Okay. If this is not a square, if this is a rectangle, then you're going to have it like then you're going to have a different base over here. So you're going to have this kind of situation. Okay, so if you have rectangle. But again, this would be the perimeter. So the area of the lateral area, so LA, the LA will equal to 1/2 the base, the total base, right? So that's your perimeter times the height would be the H. Okay. Okay, so let's go ahead and do example 18-11. Okay, from the total surface area, so you're looking for TA of a right circular cone. Okay, so it's a cone. And it's right, so it means it goes straight up and down with a radius of 5 and altitude of 12. Okay, so we're looking for total area. Okay, so you have radius of, so this is 5. So by using Pythagorean theorem, 5, 12, 13, right? And you're looking for total area. So total area, okay, will equal to the lateral area plus 1 base. Again, capital B means the area of the base. Okay, so you want to separate, right? So LA, again, if you cut this open, you're going to get this, and this would be a 13, and this would be a 2 pi r. Okay, so you have this kind of situation. Again, 13. Okay, you write it 3 times to help you to visualize. Okay, so LA would be equal to 1/2 base, right? 1/2 base times height. So LA will equal to, so you want to go off to the side so it doesn't kind of clutter up your major steps. So it would be 65 pi. Okay, and the B is the base would be pi r square. So B will equal to 25 pi. So you put it back over here, so you got 65 pi plus 25 pi, and so the total area will equal to 90 pi. Okay. Okay, now let's go and sum up the relationship between all 4 shapes. Okay, so here, so notice that the total area equal to the lateral area plus the 2b. Okay, again, because you have the bottom base, you have the top base. Okay, the pyramid, the pointy top, you have only 1 base. So notice the formula again is LA plus 2b. This is LA plus 1b. Okay, because there's only 1 base. Now obviously they're not going to have the same lateral area. To find the lateral area, you can just find each individual. You can add it up. This one you can just find each individual triangle. You add it up. Okay. Now to find the lateral area, each one of these is a rectangle. So it'd be just, if you open it up, it would be just the perimeter times the height, right? Perimeter would be the base, the total base. Okay. Now over here, because it's a triangle, so it'd be 1/2 base, right? And this is the total base, right? So base would be your perimeter times the height of the triangle. In this case, the lateral area is not the H. Okay. This L is this right over here, the slant height. Okay. And the volume is equal to the base area times height. Whereas when you have pointy top, it's always 1/3. Okay, so you can see the relationship. Okay, so it's the base area times the height give you the volume. And if it's a pointy top, it would be 1/3. So this is 1/3 of that if they have the same base. Okay, and if you compare the formula, okay, see over here. So cylinder is the same thing, right? See the total area equal to the lateral area plus 2b. So over here, the prism is the same thing. Right? Total area is LA plus 2b. So when you have something that goes straight up and down, okay, you're gonna have 2 bases, right? You have the plus 2b. When you have a pointy top, you only have 1b. Okay, see that? Okay, so see the relationship, right? And then you look at the LA, okay. Again, this one would be 1/2 because this is a triangle, this is a rectangle, so this would be 1/2, okay. And over here, again, this, if you open it up, this is a rectangle. If you open it up, so C is a circumference. So when you open it, you get the circumference times the height is a rectangle, right? When you open it up, this is a triangle. Okay, it's a sector, but you can apply the triangle technique. So it can be 1/2 the base times the height. Okay? But again, remember when you open it up, the height is not the h. So this is the h, the altitude. So this L is a slant height right over here. So it's going from here to here. Okay? And again, the volume, if you look at the volume, see when you go straight up and down, the volume is base area times height. Okay? Base area times height, right? When you have pointy top, you're going to have 1/3. When you have pointy top, it's 1/3. See the formula? They're exactly identical. Okay? And again, look at the formula for the LA. Again, it's identical. Okay? So it's a perimeter. See, it's a polygon, so you get a perimeter. Over here, it's a circle, so you get a circumference. Right? Okay? And again, you get the +1 base, +1 base. Okay? Again, same thing over here. Okay? Over here, the prism, when you open it up, it's a perimeter times height. Over here is a circumference times height. Okay? So you can see the close relationship between the four. Okay, so I'm going to move this over here so you can look at. Okay, I'm going to do it this way so you can get a really good picture of this whole thing. Okay, I'm trying to get a good picture so you can see the relationship between the four.